Thermochemistry Extra Problems, example number 1. In this problem, we see that we put a piece of metal that we've heated up to 9619 degrees Celsius, and then we drop that warm, hot, however you want to look at it, metal into a coffee cup calorimeter or some kind of calorimeter. And that water starts at 4311. So the way this problem reads, that this metal starts at 96.19 degrees Celsius. So 96.19 degrees Celsius. Perhaps that was heated up in on top of a stove, or however the source might have been. Probably in our case, we would have heated this up in a boiling water bath. Okay, so we get the boiling water bath to 9619, or that's how high we got it. We assume if we leave it in that long enough that all of the molecules of the metal are at that same temperature. So a little bit of assumption there. Then we put that metal into 67.50 grams of water, and the initial temperature of that water is 43. It says calculate the final temperature of the metal and the water mixture, assuming no heat is lost to the surroundings. So this is a traditional transfer of heat problem where we're putting hot metal inside of a coffee cup calorimeter or calorimeter and seeing what the final temperature. Remember, in this problem, what's going to happen is that hot metal is going to heat up the water, and the water is going, and as that happens, they're going to both level off. So eventually the temperature of the metal goes down as the temperature of the water goes up, and they equal each other. So we can set the Q equations, Q metal equal to Q water. Now, one side is transferring heat to the other. You determine that based on whichever one's at the highest temperature, because heat's going to transfer from higher to lower temperature. So remember, our metal starts out initially at 9619, and our water starts out at 4311. So the side that's going to be negative is the metal side. Now, we have no formula for Q, so there's no Q's here. Q would be a joule of heat, and no joule of heat is given, or kilojoules, or any kind of unit of heat of joules. Yes, there's a joules here, but that's a specific heat, which is a joules per gram degree Celsius. Not the same. Just because it has joules doesn't mean that it is heat. Okay, it's a specific heat, different than a regular heat. So we're going to set the Q's equal to each other. Okay, so remember that Q is M times C times delta T. In this case, M times C times TF minus TI. Delta T, the triangle T, is what this comes from right here. And it's always TF minus TI. And then on the other side for water, MC delta T. So we have Q metal equal to Q water. Notice everything looks very similar. This whole side is everything about water. This whole side will be everything about metal. This negative out here is because we know that the metal is warmer and it's transferring heat to the water. So we're going to put this negative out here, and now we're going to plug numbers in from up here. Okay, so this was the formula we had just a moment ago on the previous page. Now we're going to begin pulling numbers from up above. So I have my negative, my M for my metal, because remember this side is the metal side, my specific heat for my metal, we're solving for TF. Remember, the TFs will be equal eventually when all the heat is transferred. So TF minus TI, remember our metal was heated or started at 9619. On this side, this is the mass of the water. This is a specific heat of water. It's on your formula card, or it's a standard that you should have memorized. And then TF minus the initial temperature of water. Now, the rest of this is all algebra. Okay, so let's talk about what we're going to do in this first step. To get the 6886, I took these two numbers and multiplied. So they're right here. I kept my negative out here for now. So now these two numbers multiplied goes here times this. And then 6750 times 4.184 is 282.42. So all I did was multiply the two front numbers here and got this. These two front numbers and got here. Next step is to distribute or multiply the numbers through. So that's what I did here. Kept my negative out here still. I took the 6868 and multiplied by T, and the 6886 times T and 6886 times 96. When I did that, I got this. 6886 times T is 6886T, and 6886 times 9619 is 6623.64. And you can see how units cancel as you look at this. On this other side, I'm going to distribute also. So I took the 282.42 times TF and the 282.42 times 4311. When I did 282.42 times TF, I get 282.42 TF. You can call this X if you want. 282.42 times 4311 gets 12175.13. If the TF is confusing, you can always let TF equal an X if that makes it easier for you. All right, so this was the problem right here that I just got through by distributing. Next, in this line right here, okay, before the green slash, I distributed my negative through. So meaning from this line here to this line here, I took the negative. So this is negative, but negative times the positive makes this positive. This side had no negative to distribute through, so I kept it like it was. And now I'm going to combine terms. So what I'm doing here is I subtract both the TF side from this side to get the two TF sides on the same side. So I subtract this TF side from this over, and this goes away. When I subtract it over on this side, the left-hand side becomes the negative 351.28. Okay, negative 351.28. So again, I'm trying to combine like terms. So I have a TF and a non-TF. I had a TF and a non-TF. So I'm subtracting this TF from this side and subtracting from this side. That's how I got the negative 351.28 TF. Plus the 662364 equals this. So now this has to go to this side. So this is the non-TF. So I'm subtracting 662334 from both sides. When I do that, I get this piece right here. So this side was from here. This side, the negative 18798.77, was a result of taking this value minus this value. Remember, this whole process from this step here down is I'm combining like terms. So then I have a negative 351.28 TF equals negative 18798.77 non-TF. I'm going to divide both sides by what's in front of my unknown, my TF, or my X here. So I'm dividing both sides by 351.28. So I'm dividing this time, hence the line. When I divide that, that's how I end up getting the 5312 degrees Celsius. I would highly suggest that you plug things in and understand where they come from, and then go through the math yourself, understanding how I get each of my numbers. If something does not make sense, please reach out.